Welcome to educator.com. Today we're going to be discussing from sentences to equations. And this is extremely important because sometimes you'll be given a sentence rather than the actual equation. So you're going to have to take the sentence and translate it into an equation yourself. In real-world applications, that's what you'd have to do a lot of times when you're using algebra. The strategy is to use variables to represent unknown numbers or values. And for a variable, we use a letter. And you can choose whatever letter you would like to use, X, Y, Z. And when you are given an unknown value in an equation, you're going to use a letter instead to represent that. The second thing is to read the sentence and translate the phrases in the sentence into arithmetic operations. For example, if it says the sum, then you know that you're going to need to add, or the difference, subtract, or product, multiply. Very importantly, you need to identify the word or phrase that indicates equality. In other words, you have to figure out where to put the equal sign. The equal sign splits the equation into two, into the left and right sides. So once you've identified where the equal sign goes, then you can approach the equation from the left side and then do the right side. So using these strategies, we'll do the first example. Write the equation for 4 times the number decreased by the square of that number is 1 more than 3 times the number. Okay, I see that I have an unknown. They say a number, but they don't say what the number is. So I'm going to pick X to represent a number. So whenever they talk about this unknown number in the phrase, I'm going to use X in my equation. The second thing I'm going to do is figure out where the equal sign goes so I can see what the two sides of the equation are. 4 times the number decreased by the square of that number is 1 more than 3 times the number. So it's saying that this first phrase is or is equal to the second phrase. So is tells me that's where the equal sign goes. I'm going to work first with the left side of the equation, translating the phrases there into numbers, variables, and arithmetic operations. 4 times a number. So it's saying 4 and multiply by a number, which I've called X. Decreased by. Decreased by is telling me to subtract. So 4X minus decreased by the square of that number. That number is X squared. So I have the left half of the equation is equals 1 more than 3 times the number. This is telling me that I need to add 1 to 3 times the number. It's 1 more than 3 times the number. 3 times, so multiply the number, which is X. When you're finished writing the equation, read the sentence again and double check that you've written everything correctly, that you've translated correctly. So 4 times the number, 4X. Decreased is subtraction by the square of that number. X squared is, so I have my equal sign, 1 more than, I added 1 to 3 times the number. So 4X minus X squared equals 3X plus 1 is the equation for the sentence that I was given. Here's a longer example, but use the same techniques. Write the equation for 3 times the sum of a number and the square of another number is 5 less than the difference of the cube of the second number and 5 times the first number. Now that's pretty long, but we're going to follow the same strategy. I have to assign variables to unknowns, and in this case there's actually 2 unknowns. It says the sum of a number and the square of another number. So there's actually 2 numbers. I'm going to let the first number be called X. That's a number. And then another number tells me there's a second number, which I'm going to represent as y. So I have my two variables, and now, especially because this is a long equation, I need to figure out where the equal sign goes. 3 times the sum of a number and the square of another number is. Is tells me that this first half, this whole long phrase, equals everything that comes after. Working first with the left side of the equation and translating that into numbers, variables, and arithmetic operations. 3 times. Okay, so I've got 3 times. And it's 3 times the sum of these two terms. 3 times the sum of a number. I decided to call the first number x, so it's going to be 3 times x, and so the sum of x plus the square of another number. Well, the other number is y, and they want me to square that. So I have the left half done. 3 times the sum of a number and the square of another number is equals. Here's where things get a little more complicated, because what they want is 5 less than the difference of the cube of the second number and 5 times the first number. When you see 5 less than, the temptation is actually to write 5 minus. But that's incorrect, because it's saying that what comes after needs to be subtracted by 5. If I say that Justin's age is 5 less than Taylor's, I'm actually going to take Taylor's age and subtract 5. So when you see something less than, you actually put minus at the end. So 5 less than tells me that minus 5 is going to go way over there, and I'm going to subtract from the phrase that comes after. Okay, so I have my minus 5, and now I need to figure out what I'm supposed to be subtracting 5 from. And it's saying that I'm subtracting it from the difference of the cube of the second number, so the difference between two terms. And one term is the cube of the second number. The second number is y, so y cubed, and they want the difference, so the y cubed and 5 times the first number. Going back to check, 3 times the sum of a number and the square of another number. So 3 times x plus y squared is equals 5 less than. So subtract 5 from the difference of the cube of the second number, y cubed, minus 5 times the first number, which is x. So this equation is translated from the sentence that we were given. The third example involves age. Write the equation for Mary's sister is 5 years younger than she is. The product of their ages is 5 less than the square of the difference of their ages. I actually have 2 unknowns here. I have the age of Mary's sister, and I have the age of Mary herself. Just looking at this first sentence, Mary's sister is 5 years younger than she is. So Mary's sister is actually 5 years younger than Mary. Let's let Mary's age equal m. Now, I could assign a different variable to Mary's sister's age, but I don't need to, because they actually give me the relationship between Mary's age and her sister's age. What they tell me is that the sister is 5 years younger. So whatever age Mary is, m, I just subtract 5 from it, and I come up with Mary's sister's age. So instead of having 2 different variables, I can express these both in terms of Mary's age and just use one variable. Then I read the second sentence. The product of their ages is 5 less than the square of the difference of their ages. And I need to express that as an equation. I already have my variable set up, and now I see that the product of their ages is, so I found my equal sign. And I can go ahead and start translating the first half of the equation. The product of their ages. Product means multiply. And they want me to multiply Mary's age and Mary's sister's age. That gives me m times m minus 5 is, so equals 5 less than. We saw this before, and it's the same thing here. When you have something less than, you put the minus 5 or minus 3 or minus 1 or whatever they give you at the end of the term that comes after. What this is saying is to subtract 5 from the square of the difference of their ages. Okay, so I have the minus 5, and I need to figure out what it means by the square of the difference of their ages. Well, the difference of their ages means I need to subtract. And I'm going to take Mary's age, and Mary is older, so I'm going to put that first, and I'm going to subtract Mary's sister's age, m minus 5. This says the square of that difference. Okay. Double checking, the product of their ages is 5 less than, so the product of their ages, m times m minus 5, is 5 less than the square, I have the square, of the difference of their ages. So Mary's age minus her sister's age squared, less 5. Take away 5, subtract 5. Looking at this, I can actually make it simpler. The left half of the equation I'm going to keep as m times m minus 5, but let's look at the right side of the equation. You'll notice that I have m minus m. That's 0. So instead of writing all that, I can just eliminate the m's from the right side of the equation. That leaves me with negative 5 squared minus 5. And I can even go 1 or 2 steps further and finish doing the math on the right side. M times m minus 5 equals 20. The final example asks us to write the equation for the surface area of a cylinder. And the surface area of a cylinder is the sum of 2 pi times the square of the radius and 2 pi times the product of the radius and the height. For the surface area of a cylinder, I'm going to use S, because that is an unknown. I don't know what it is, so that equals the surface area of a cylinder. And then I look through, and I see I actually have 2 more variables I need to use. 2 pi times the square of the radius. I don't know what the radius is, so I'm just going to call it r. And 2 pi times the product of the radius and the height. I also don't know what the height is, what the value of the height is, so I'm going to call that h. Okay. Looking through, the surface area of a cylinder is, my equal sign is towards the front, so the left side of the equation is just S. The surface area of a cylinder is the sum of, so on the right side of the equation, I'm going to be adding 2 pi times the square of the radius. So it's telling me to add 2 things. The first term is 2 pi times. Times indicates multiplication. So I can put a dot there, or I can just leave the dot out and continue on with the square of the radius. Okay, so the right half of the equation is the sum of 2 pi r squared and plus 2 pi times the product of the radius and the height. So again, multiplying. 2 pi times I'm multiplying the radius and the height. So the surface area of a cylinder is S equals 2 pi times the square of the radius, 2 pi r squared. And so add, because it's a sum, 2 pi times the product of the radius and the height. And this is the actual formula for the surface area of a cylinder. A cylinder is a closed tube, so it's a solid tube. It has a top and a bottom on it, whereas the tube is hollow. And if you look at this, you'll recognize pi r squared as the area of a circle. And since there are 2 circles on the end of the cylinder, you're going to need to add 2 of those to get the surface area. So it's really saying 2 times the area of a circle plus the area of the tube part, the tubular part, which is 2 pi rh. So this formula makes sense when you break it down. Thank you for visiting educator.com.